Alrighty, what's up, everyone? This marks pretty much halfway done with review. And what I'll say is, if you're still with me, I really think you're going to do well on this test. Um, Probability is, in my opinion, the hardest part because after this one, we're going back to stuff that we've done a lot recently. So this is kind of the last really technical and this is the last one where you really have to dig back into remembering some old stuff. Um, but after that, I think we're doing pretty well. Okay, so we're in review set 4. And this one, there's one question on here that I absolutely love, the one I'm going to do for the second set. But our big two topics are the binomial distribution and the normal distribution. And as a concept, probability is hard, right? There's a lot of these really long and tedious formulas, but if we can boil down a question, oh, my bad. I've had like a lot of coffee, like the Starbucks things, so like a lot of milk too. Anyway, um, probability is really difficult, and if we can boil it down to something we can plug into the calculator, that's probably our best bet. Okay, so we know that we have normal distribution and binomial distribution. We'll kind of talk about when to distinguish between the two of them, and basically try to boil every question down into inputs into the calculator. So read the question. We're talking about a smartphone developing a new battery, and I think this is a really cool question. And first, it talks about basically how many months the battery of a new phone lasts before it just dies. And it says that on average, a phone lasts 30 months with a standard deviation of 8 months, and that is normally distributed. Okay, so we can make a normal graph of that, but that seems pretty reasonable based on real life. And then it talks about a warranty. And the idea is if you pay $50 and your phone breaks within the first 24 months, then they're going to give you a new phone. Okay, so I think this is a really fascinating, really cool question, and something that you could really do on your own. I mean, you probably wouldn't do it exactly this way, but think if you're a business trying to mitigate risk, that could be like a cool application of this. So we're trying to figure out, is this warranty worth it? That's the whole gist of the question. But before we do that, A just asks us, in how many months from the date of purchase is it expected that 25% of the batteries will no longer work? And my recommendation for the normal distribution, and I think I do this way more than pretty much all of you, is I like to graph every question. And that becomes especially useful now that you're seeing a bunch of different types of question, because sometimes in my worksheets we do the same type of question. It's not too much variety. I mostly practice like the skills themselves. But if you're seeing a completely random question and you want to know what to do, you should draw it. And it's saying how many months is expected that 25% of the batteries no longer work. And before we overthink it, let's just put in the mean. That's where you start with every single normal distribution graph. And it's not 300. It should be. Apple's pretty evil. I mean, like all corporations are, but they could figure that out. That'd be so much cheaper for everyone. Okay. But yeah, whenever you start a normal distribution graph, you start with just putting in the mean. Okay, and the mean was 30 months. And what it's trying to say is how many months from the date of purchase is expected that 25% of the batteries no longer work. Okay? So if we're thinking about this, we want to find where we go. Think these are months, right? So 10 months, 20 months, 30 months, etc. We want to figure out what month 25% of the batteries stop working. Okay? And maybe you can already see how this could apply to thinking about the warranty. But this is a pretty standard normal distribution question. It's giving us the percent below the graph, and we're asked to convert that to a z-score and then a data point. Okay? So in the example we did yesterday, we started with the data point and we found this percent. But remember, you can go both ways. You'll use inverse norm in the calculator instead. But here's what we have. Okay, so we want to figure out this point, and we have this percent of data. Yeah, I'm so happy. Before I did the lesson, I was like, you have to find your one copy of this thing. And then I forgot to, and I was like, oh man, I'm going to have to go find it, get out of the zone. But I found it really quickly. You should see how many papers I have over there. That was really lucky. Okay, so here's the question. And we want to figure out this data point. But to find that data point, we're going to start with percent below. And we're going to convert that to z. Because remember, this chart takes a percent of data, and it says this z-score has that much data below it. Okay? So you can plug a z-score in and find this percentage, but you can go backwards, and you can find the z-score given this percent. If this percent is 0.25, we're trying to find that here. And hopefully we remember this. This one's marginally closer, negative 0.67. And the next example I have of this, tomorrow I'm going to do it the calculator way, but I think it's way more kind of intuitive, at least now, to think normal distribution. Okay, so negative 0.67 is the z-score. So we know that whatever data point this is, damn, the Pinot announcements just disrupted my stream. But so what I was trying to say is, whatever data point this is, it corresponds with this z-score. We have to figure out if the z-score is negative 0.67, what data point is that? And it's all about manipulating this formula. And I think I really did tell you in January, this formula is the whole course, because this is also inference. But we're given this, we know the standard deviation was like 8, and we know this is 30. And no need to worry about like a sampling distribution or anything, because it's not saying sampling distribution. It says this is the normal distribution. So if we know this, this, and this, we can solve for data point. And I'll zoom through that, multiply by 8, this number, add 30 to it. And we'll get 24.64 months. So what that means is around 25% of the time your phone is going to die within 2 years, okay? So that was the beginning of this. And now let's do B. It says, suppose one customer who purchased the warranty is selected at random. What is the probability that the customer selected will require replacement within 24 months from the date of purchase because the battery no longer works? Oh, okay. I remember I did this question last year, and I think it seemed much trickier to me. And I don't think it'll be too tricky for you either. So what this is saying is, how likely is it? What is this percent if the months is 24? Okay, so if it's a warranty, let me just draw at the beginning. I got a little flustered because I got it. I knew what to do. And all this is saying is, look, 30 is the average. But if you're Apple, you want to know how likely it is that it's less than 24. Because these are the people who are going to use the warranty and cost you money. Okay, so if you're trying to figure out your risk, we want to figure out what this probability is. And if this probability is too high, they might want to lower their warranty number of months to like 18. So A and B are so similar, except for one of them you start with the data point, and one of them you start with the percent. So this one we're going to work backwards. And what that means is we're starting with 3 pieces of data in the formula. To find the z-score, and then we put the z-score into the chart. And that z-score is really close to this z-score because we figured out that 25% is 24.64. Okay, so this is going to be really close to 25%. It's just going to be a little bit, let's think about it, a little bit smaller. So that's my z. And once you have one of these two things, you can find the other. So we know this corresponds with negative 0.75. What percent corresponds with that z-score? Negative 0.7. So 0.2266. Hopefully that makes sense. Pretty cool though, I think. And really not so bad, but that's a really good start. With C, this is where it gets really interesting, and this will be the last time we talk about expected value. And all the expected value questions are kind of logic based. So it says the company has a gain of 50 for each customer who purchases a warranty, but they have a loss of 150 if they do need a replacement. So if we're trying to put that in really simple terms, it means that if you break your phone, it's going to cost them $150 if you use the warranty. But if you don't use the warranty, they just got your $50. Okay? So now it's saying, what's the expected value of the gain for the company for each warranty purchased? And this is really, really easy, okay? But I don't think that, I think it makes sense not to get it right away. But once I show you, it's going to make a lot of sense. Now what's hard is this graph, we know it's really fluid, and there's a lot of percentages here. But this graph, there's only two parts that matter for the company. The percent of the time where you have to use your warranty, and the percent of the time that your phone lasts longer and you don't use the warranty. So we're going to draw a little probability distribution table. Okay? So there's two outcomes, right? Hello?
Hello?
Hey, how are you?
Hi, Juan from Comcast.
Oh, hey, what's up?
Okay, so looking at your plan, you do have, like a starting level internet service.
Yeah.
So what kind of internet speeds were you looking for? Or what were you looking to do now with your internet?
Well, I just don't want to have to get any new equipment, but I would go, I only care about the upload speed, but I would go as high as I could, really.
So, let's see. So, I do have so for $30 extra, you're able to get, so you're going to go from, I think you're like a 20, let's see what you're at. So you have the plus, so you've got 25 megabits per second. So for $30 more, you'll be able to do, it'll give you 300 megabits per second.
Whoa, okay. And is that the same with upload speed?
I'm sorry?
Does that also affect, the upload speed?
Right, so it'll be, so it'll give you, I think you're at 3 or 5. This will jump you up, I believe, to 10 or 12.
Okay.
And then you can always, so if you look into, so you also got a promotion that expires in about 2 or 3 months. For now, we can change it to, so you still will keep the $29.99 promotion. We're just going to add $30 to it, which will give you faster internet upload and download speeds.
Okay,
So,
yeah.
But come July, you want to come in so you can definitely get something that's, because it's going to go up from the 30 anyways.
Okay, yeah, that's perfect. I'm good with that idea.
Okay, so then if you want to just do that, you want to just up it to 300 megabits per second?
Yeah.
Okay, so we're going to just do that. It'll start now.
Yeah. Okay. Thank you so much. So it's gonna work right now, like immediately.
Yeah. So just restart the modem. So just unplug it and then replug it.
Okay. Cool. Thank you.
All right. Here we go. Every day.
Have a good day. Let's go. Yo, squad. This video has been interrupted twice, but I just got off the phone with the internet dude, and I'm gonna have like, I spent like 30 extra bucks to get faster internet for the next few days. So my upload speeds are gonna go, I think 5 times faster. I really hope, because it takes me, like 7 hours to upload a video. So literally, my computer hasn't stopped uploading for like 3 days now. But I'm hoping if I can do that, then like, what if I had like 10 videos in a day? Like, that would be heroic of me. If it's not too late. I mean, if you're watching this, it's really not too late. But yeah, I just got faster internet. So let's finish this question. I'm on a roll, kind of with life. But yeah, what we're trying to figure out is the economics really of this warranty. Okay, so what we're trying to do is figure out the expected value for the company if they do this warranty. And the big gist is that there's only 2 things that could happen from the company's perspective. Either someone's going to take the warranty because their phone broke before 2 years occurred, or they're not going to take the warranty because their phone didn't break. Okay? And we found that this percentage, the percent of the time that they use their warranty, is 0.2266. We're going to skip what happens to that just to start. But this is what happens, or this is if the company, this is the percent of people who need the warranty. And then the rest of the time, people don't need the warranty. Okay? And remember, what we're really creating is this really simple probability distribution. But we want to figure out what happens for the company in each of these cases. So first, if they use the warranty, that costs them $150. Okay, and that's what it tells us here. If they don't use the warranty, they get $50 because the customer paid that money. So if I want to figure out the expected value, it's just this times this plus this times this. And hopefully that makes sense. And I think it's super cool. And you don't need this probability distribution, but I'm a visual person clearly with all these graphs. All you would really have to do is multiply the percent to these 2 values. So it comes out really close to 0, and I think that that's pretty intentional. But we're going to get $4.68. And what's really cool about that is that's like the exact math that the business would actually partake in. So in this case, this seems like a pretty reasonable profit for something that is reasonable for the company to do. A 2-year warranty for $50 seems like a pretty good deal, but the company is ending up on top. Okay, so this is expected value. This is normal distribution, and we'll cover a little bit more normal distribution in the next video, but I think that this went pretty well. Woo.